Hey everyone, it's John. Today I'm going to do a video on how to configure router on a stick, and with that also configuring DHCP on the router to allocate IP addresses to all the different hosts on the network. So let's just start. As you can see, I've got a basic topology here. I've got 4 separate VLANs, VLAN 15, VLAN 25, VLAN 44, VLAN 65. And we've got a basic switch network here, and up the top we've got a router which will be allocating the IP addresses. And yep, that's pretty much it. So let's just start. Okay, the first thing that I'm going to do is configure the VLANs. So if we do conf t, I'll just make this switch 1 so it's easily identifiable. Right, when you're configuring VLANs, this is quite a small network, so you really could just go into every independent switch itself and just manually type in every VLAN repetitively. However, just for efficiency and for purposes of working on larger networks, I'm going to just throw in a bit of VTP, which is VLAN trunking protocol, which allows you to propagate one VLAN configuration throughout the network so long as they're all within the same VTP domain. So let's just start and do that. So the first thing I'm going to do is do Vtp Mode Server. It should already be in that anyway. Yep. Okay, so we need to actually specify a group name for the VTP. So we'll do VTP and we'll do domain. And the domain we're after is any name you want. So I'm going to just call it Tango so it's quite identifiable. Right, so up the very top here, switch number 1 is being configured as a VTP server. Now, a VTP server means it will propagate the VLAN information, and can also delete and add VLANs, so on and so forth. The rest of the switches will be configured in VTP client mode, which means that they can receive the VLAN information and they can propagate it to other switches, but they can't actually delete and add VLANs. So the first one we'll do is, as you can see, to go along with the format, we've got VLAN 15, and the name for that will be finance. And the next one is VLAN 25, and like that, design. Next one will be VLAN 44, name can be tech. And VLAN 65, name marketing. Right. So that's them configured. If I do a show VLAN, you'll see that they're all there now, they've been created. However, obviously on the other switches, let me just go down here. If I do enable, actually I'll do a show VLAN from here. On the rest of the switches, you'll just have the basic default settings. So what we want to do is essentially configure these to be in the same VTP domain, and then the propagation can happen and they can self-update. So we'll call this one switch 2. Actually, see, before I do that, what I'm going to do, if you excuse me, I'm going to go to this switch and I'm going to configure, see these 3 links, the 1, 2, 3. I will need to configure each of them to be trunk ports. Now, if you're connecting a switch to a switch, it has to be a trunk port, and for the VTP propagation to happen, it needs to go over a trunk link. So I'll actually just configure this. So let's get the switch ports. That's FAO3, FAO2, and FAO1. So what I'll do is I will do conf t, and I'll do int range FA01 to 3. And I'll do switch port mode trunk, switch port, trunk allowed VLAN, what have I got, is it 15, 25, I think it was 44 and 65, is that correct? Believe so. Yep. Okay. So now you'll see these are being put into trunk modes and they've went amber. Now, what I'll do is go on to the next switch. And I'll speed that along a little bit just to hurry things up. Okie doke, so switch 2. remember what I said. What I need to do is configure the actual mode so that it is a client. So I'll do Vtp Mode Client. That's in client mode, and I also need to add it to the correct domain. So Vtp domain, and we use the word Tango to identify it. So now if I do a show VLAN, it's now got the VLAN information of the original switch, which is now propagating out. Similarly, if I go on to, I'll call this one switch 3, enable conft host S3. So if I do it from the start, you'll see again, this has just got the information because it's trunking. There we go, it's propagated. So what I need to do now is go on to the other switches and configure trunk links there, because as you'll see, we've got show VLAN. These will have the defaults, and up, and again here, switch show VLAN defaults. Okay, so now these links here, which are FAO2, FAO3, and similarly FAO3 and FAO2. So if I go into these switches and I do an int range FA02 to 3 and make them trunks, switch port mode trunk, switch allowed VLAN 15, 25, 44, 65. Keep doing that. And similarly on this one, conft int range FA0, I think it was 23, wasn't it? I believe so. FA2, yep, FA2 3. And I make these switch port mode trunk, switch port trunk allowed VLAN 15, 25, 44 and 65. And I go to speed this along. Right, so show VLAN. Now you need to configure these ones to be in the correct domain. So I'll do Vtp mode client, and I will do Vtp domain and Tango, and show VLAN up, and it's now got the correct VLAN information. Okie doke. Now, over here we have show VLAN, that's fine too. Right, so we've now got our VLAN information being propagated to each switch. What I'm going to do now is allocate these ports into their correct VLANs. So the ports here will go to 15, the ports here will go to 25, the ports here will go to 44, and the ports here will go to 65. So let's see the ranges we're using. It's going from FAO4 to FAO6. So we'll do up conft int range FA0 up 0/4 to 6, and we want to make these an access port. So switch port mode access, switch port access VLAN 15. If we do a show VLAN, they have now been placed into the finance department. Similarly, range 5 to 3. So conft int range FA0 3 to 5, and we'll make that switch port mode access, switch port access VLAN 25, show VLAN, and these have now been placed into the design department. the range here is going from FAO3 to 5. Yep. I'll make this host, what's that, S4. And I'll do int range FA, what was that, 4 to 3 to 5, I think it was. 3 to 5. 0/3 to 5. Switch port mode access, switch port access VLAN 44. And I'll show VLAN. And these have been configured to go to the tech department. And similarly, up here at the top, we've got FAO4 to FAO6. Int range FA0/4 to 6. And we'll do switch port mode access, switch port access VLAN 65. Now if you notice when I click this, they go amber and they're going to go through a spanning tree process. You can actually speed that up by making them port fast, which will actually put them straight into forwarding mode. You only do that when they're connected to, for example, an actual host. Do not do it if it's connected to a switch, because you can actually get problems with that. You can get loops. So what to do is, you'll see that go to amber. We can speed that up by doing spanning tree port fast. That will green them straight away. And a good idea is to also put BPD UGuard on. Yes, spanning tree, BPD UGuard, enable. That means a BPD UGuard basically means if it receives a BPDU, i.e. from another switch, it'll actually shut the port down, so you're okay, you won't get an actual loop. Right, so let me just show int trunk. We are now trunking on those ports, which is fine. Okay doke. Now, as a note here, before I go on to configuring router on a switch, you'll notice we've got spanning tree going on here. We've got some block ports. You can actually make this slightly more efficient just by, because we're using Per VLAN Spanning Tree, you can actually use a separate instance of spanning tree for each VLAN by making different switches the root port for different VLANs. So for example, if I go onto this switch here and I do show span, you'll see that every one has got the same root port, root bridge, and for every VLAN. So 65, it's out of fast Ethernet 01. So if you did a show CDP neighbor, you would see that actually connects to this switch here. And if I do a show span, you'll see this bridge is the root, that's for VLAN 1. This bridge is the root, that's for VLAN 15. Same again, 44, 25, it's the root for every single one. So if you want to make that a little bit more efficient, you could spread it out and change the spanning tree a little bit. So we can do that just now, just for an example. This isn't exactly perfect design, to be honest with you, but we'll just do it just so people can see. So what we want to do is do spanning tree VLAN 15, and we'll make this the root, we'll make this the primary root. And on this one here, we will do conft spanning tree VLAN 25 root primary, make that the root, and 44 on this one, conft spanning tree VLAN 44 root primary, make that the root, and conft spanning tree VLAN, what was that, 65, isn't it? Yep, 65 root primary. Okay, so if you do like show spanning tree, you'll see that, for example, on 65, this bridge is the root. Similarly, on the one next to 15, if you do a show span, you'll see that this bridge is the root for VLAN 15, and you'll notice those ambers have gone. So that's just a little bit of messing around with spanning tree. So now what we want to do is essentially allow, or rather configure, certain DHCP pools on the router, which can allocate out to each VLAN to go through a certain hierarchy of addressing. So let's start with that, and we'll do. Okay, the address scheme which I'm going to use is very, very basic. Essentially, the default gateway will be the first address in each network. As you can see, I've got a 15.0, so the address for the default gateway will be 15.1, and this one will be 25.1, on this one will be 44.1, and this one will be 65.1. Very, very simple, just keep me easy to follow. So we'll do enable conft, we'll just call this R1. Okay, now, when you're configuring DHCP, you're actually going to configure separate pools for each one. So to make it identifiable, I'll do VLAN 15 will be called pool 15, VLAN 25 will be called pool 25, VLAN 44 will be called pool 44, and VLAN 65 will be called pool 65. However, when you're actually excluding the addresses, so for example, the actual addresses you do not want to allocate, i.e. the default gateways, they're not going to be allocated, they're going to be basically configured on the router and not handed out to the hosts. You actually need to configure that globally, not within the actual individual pools. So do IP DHCP excluded address, and the first address we'll exclude will be 192.168.15.1. IP DHCP excluded address 192.168.25.1. IP DHCP excluded address 192.168.44.1, and IP DHCP excluded address 65.1. So that's you essentially excluded all those addresses, so they will not be handed out when you come to actually configure your DHCP pools. Now, what we want to do is the IP DHCP pool, and the first pool we'll call it pool 15 to denote the pool for VLAN 15, and the default router, which will be the default gateway, will be 192.168.15.1. that is the address we're not allocating out, we're actually going to configure on the router. And the network will be 192.168.15.0, and the mask will be a /24, and the DNS server, we'll just call this, we'll just use Google's public DNS, even though it's not actually going to work, just for purposes of example. So now the next one we want to do is IP DHCP pool, and we'll just call this pool 25, and we'll do the default router, which is the default gateway, 192.168.25.1, that will not be handed out, and the network will be 192.168.25.0 with a /24 mask. DNS server, again just use the quad 8s. IP DHCP pool, and we'll call this one pool 44, default router 192.168.44.1, network 192.168.44.0, and DNS server rather is 8888 rather, quad 8s, and IP DHCP pool, and we'll do pool 65 for the last one. Default router is 192.168.65.1. The network is the 65 network, and again /24 mask, DNS server, quad 8s. So that's us now configured the actual pools here. As you can see, we've got the address ranges all configured here. So now we've got each host configured into their respective VLANs, 15 here, 25 here, 44 here, and 65 here. So what's going to happen is the hosts here do not have IP addresses. If you go into an actual host and we did desktop and did an IP config, you'll see there's no IP address on it. What we want to do to actually happen here is to go through the DORA, discover, offer, request, acknowledge for DHCP. What it's going to do is going to send a request out here for an address. It's going to go, it's going to be tagged with VLAN 15. It's going to be sent across the trunk link is 15, and again 15 here. And what we need to do is on this router is configure some sub interfaces, and we're going to use the .1q tagging so it can identify the actual tags, and that will actually send it to the respective VLAN pool, which will then allocate back out of this link here and back to the host and give it an actual address within the address space 15.0, 25.0, 44.0 and 65.0. So if that's a little bit confusing, it might be, I know that, just watch and it probably should come quite clear after a bit. So let's configure this. First thing we need to do is actually bring the interface up. So we'll do interface gigabit 00, which is this one here, and we'll just no shut that. So that's that up, but what we need to do is actually configure sub interfaces, and the format which I'll use is each interface will correspond to the VLAN. So the sub interface will be gigabit 0/0.15 for the VLAN 15, gigabit 0/0.25 for VLAN 25, so on and so forth. So let's do that now. Conft int gig 0/0.15. This is the sub interface, and what I need to do is do encapsulation .1q, and the tag I'm going to put on the 15 is of course 15. An IP address is the actual address, remember, which we're not going to hand out. It's going to be the default gateway, which is 15.1, and we'll no shut that. And similarly, if we go into interface gigabit 0/0.25 and we'll do encapsulation .1q25 IP address, and we'll do 25.1, the address which we're not allocating out, and we'll no shut that. Gigabit 0/0.44 encapsulation .1q44 IP address 44.1/24 mask, no shut. And last one is 65, again encapsulation .1q65 IP address, 65.1. Okay, show run that, and that's all the exclusions there. That's the pools below it, and as you can see, that's everything there. And the sub interface configurations are right here. So what's going to happen is, when I go to a host, for example, like I say, I've got no IP configurations on it so far. However, if I do an actual renew here, if I've configured it correctly and not made any mistakes, it should actually do the DORA request for DHCP, and it should be allocated the first address from the pool. Now remember, the first actual address has been excluded, which is the 15.1, so this one should get 15.2. Let's see if it happens. There you go, 15.2, and the default gateway is 15.1. Similarly, if we do it on this one here, and we just renew it to get the DORA request, this one should get the next address up, 15.3. Next one, again ipconfig, and we'll renew it. This should get 15.4. See, and again, if I go to each VLAN, this port is configured for VLAN 25, so the tag will go along here as 25, along the trunk link, along the trunk, and because the router is configured with the VLAN tag, it'll go to VLAN tag 25, goes to subinterface .0/0.25, which will actually allocate from the address pool of 25.0. So this one should actually get a 25.2 address. So ipconfig, we'll renew this. 25.2, and again ipconfig renew. This should get the next address up, of course. Yep, and you can just go around this all day. This is going to get from the 44, of course, and I'll go up to here, test this one out, and we shall renew it. And this is going to get one from the 65 network, of course, and just try to ping their default gateways to make sure there's connectivity. That's that, it's connected. Up. Yep. Ping 192.168.25.1. So as you can see, it's now you're allocating. It's very, very efficient now, because you could add in any new host, and it doesn't need to be, say you happen to add in, like, let's just drag a new host on here. Okay, onto here, and let's just say you happen to want to make this part of the marketing department, even though it's not situated physically next to it. You could just connect it in. So let's make that. Okay, so all you need to do here, I'll just fast forward that along a little bit. There we go. So FA06 is connected to this new host. If we want to allocate it to, I don't know, the tech department, even though it's not physically on the same floor as the tech, you could just do enable conft interface FA06 and just make it an access port. So, mode access, and all you do is access the VLAN you want to. So VLAN 44 we're doing, and you'll see it'll go amber, and we'll just spanning tree port fast that into green, and we'll just put the BPD UGuard on that, BP, and enable that. Right, so when this sends a DHCP request, it's going to have the 44 tag on it. It'll go across the link here as 44, go up to the sub interface as 44, and be taken from the 44 pool. So let's just do ipconfig, and we should get a 44 address. There you go, very simple, keeps things really, really easy. And also if you go to the router and you do your show IP DHCP bindings, you can see all the bindings which have happened. So for example 15.2, you can actually see the MAC address it's bound to, which is EA80 ends in. So if you go to the actual machine and did an ipconfig all, you can see the actual physical address EA80. It's all there. It's all very, very simple, all easy to follow, easy to manage, and pretty efficient. So yeah, that's just a short video on how to configure that. That's router and a switch with a little bit of Vtp and spanning tree thrown in as well, and DHCP of course. And yep, that's the end of the video. So I'll probably do one next week, and yeah, I'll see you guys soon. Thanks, bye.